Pre-Calculus 5.4, Day 1. We are coming up with some new formulas here, some indifference formulas. So we have some patterns to learn and just need to learn how to do this. So sometimes we have an angle that we don't have on the unit circle, so we can't get an exact value, but we can come up with two angles that add up to it, and where that angle is on the unit circle, or subtract and that angle is on the unit circle. And then we can get an exact value. We'll see some of this. So anyway, so they have uses for getting some exact values. And we have these 6 sum and difference formulas. We have sine twice, one when the u and the v are angles, and we're adding the angles or subtracting. So then we have the cosine of either add or subtract. That's why they're the sum and difference formulas, and same thing with the tangent. And so you're going to want to kind of look for some patterns, such as notice on sine, if you have addition between these two expressions. If you have subtraction, you have subtraction between those. So with sine, the signs are the same. And I'm just talking about if you're adding the angles, you're adding the two expressions. If you're subtracting the two expressions. However, when you start examining cosine, for cosine, if it's addition here between these two expressions, you're subtracting. Or if you're subtracting, you're adding. So those are some things to watch for and get straightened out as you go through those. So anyway, some other things to note is this angle here you'll see in the first spot in each of those, and that's the pattern I want you to follow. While the second angle you'll see in the second spot. And that's true throughout. Notice all the way down, that second one we're putting in V for sine and cosine, sum and difference. While all the way down, we're putting that first angle in that first slot. Just trying to have you see some patterns, because in a normal year, you would have to have these memorized. You would not have this to rely on like you do this year with notes. So anyway, then with sine, you use both a sine and a cosine, but they switch. Sine, cosine, then cosine, sine. And that's the order I want them in. But when we get down to cosine, cosine has cosine of each angle first and then sine of each angle second. And there's some patterns to look for within tangent as well. But let's go ahead and look at this a little bit. So find the exact value here in example 1 of sine of pi fourths plus pi thirds. Well, this is a sum of two angles, and so I want to follow this one right here. And so where I see u, that pi fourths is going to be u. So as I start writing this out, this is going to be sine of u times cosine of the other angle. And since it's sine, the signs are the same. So since you're adding the angles, you're adding here. But then we switch it up and put cosine first of that pi fourths, and then sine of the pi thirds. So that u, that first angle, which they call u, goes here, while that second angle is in the second spot. Now, once you get that replaced, you should know these values using your unit circle. Sine of pi fourths is root 2 over 2. Cosine pi thirds. I'm always thinking, okay, pi thirds were like this, so you go short and then long, so cosine is 1/2. You need to show you need to start with the original problem. You have to show each of these. You can't just skip to this. I will not give you credit. You've got to show how you substitute into each one, and then you need to show what each of their individual values are. So cosine of pi fourths is also root 2 over 2, but sine of pi thirds is root 3 over 2. And then we're going to go ahead and multiply those out. I have a root 2 over 4 plus a root 6. Root 2 times root 3, multiply the insides, and then we have it over 4. And since we have a common denominator, we'll write that root 2 plus root 6. You can't add those. You can multiply root 2 times root 3 and get root 6, but root 2 plus root 6, they're not like terms, so you can't add those. And that's your answer. That's the exact value. Now, compare this to in part B, where we have sine of pi fourths plus sine of pi thirds. In this one, it's not a sum of angles, it's a sum of two sine values, and it would be root 2 over 2 plus, then the sine of pi thirds is root 3 over 2, which we could write root 2 plus root 3 all over 2. And again, the root 2 plus root 3, you can't add those, and that would be different, but that's not using that sum and difference. Okay, so now we have a cosine, and we have cosine of a difference. So I'm going to go ahead and just, oops, I wanted to copy it, but I didn't hit copy. And I'm going to see if I can paste that right here and move it so that I can kind of have that image right here as I scroll up. So cosine of u minus v, remember I said when it's sine, the signs, S-I-G-N, are the same, but with cosine, if it's subtraction, you're going to get addition between the two terms. The other thing is in cosine, the first one starts with cosine, cosine. And so it's going to be cosine of this first term, or cosine 120 degrees, and then times cosine of that second angle. When they're degrees, you should put degrees. And then it's addition. And then we do sine of that first angle. And then again, sine of that second angle. So in cosine, remember that this is opposite in terms of if it's a difference, you're adding these two terms. All right, so then after that, it should be like, oh, well, this is a breeze because cosine 120, I'm thinking it's right up here. You go left 1/2. Cosine 45 is root 2 over 2. Sine of 120 is the positive root 3 over 2. And sine of 45 is root 2 over 2. And so you get a negative root 2 over 4 plus root 6 over 4, which we will write root 6 minus root 2 usually over 4. And you can't take that root 6 minus root 2 and simplify those anymore. And there's nothing on that too for canceling. So that's it. That is it. All right. It's okay if you leave it negative root 2 plus root 6. That's fine. That's not a problem. Just have it, make sure that it's, the negative is only with the root 2 and the fraction bar, that it doesn't look like this. Because that would be wrong, because that means the whole thing's negative, and that's different. All right, so then, well, It's all nice when they give you the two angles that you're adding in there or subtracting, but sometimes you have to come up with them on your own. They want the exact value of cosine of pi 12ths. And you have to, when we give you the directions, show use of sum and difference. You've got to use sum and difference formulas. There are things such as half angle formulas, but we haven't studied those, and we'll direct you to which ones we want you to use. So you have to be aware you have to use the ones we want. So the key is that you have to write pi 12ths using a sum or difference of known unit circle angles. And so things like pi halves, pi thirds, pi fourths, pi sixths. And sometimes it helps if you take those and you get them where you have a denominator of 12, which this would be 6 pi 12ths. This would be 4 pi 12ths. This would be 3 pi 12ths. This would be 2 pi 12ths. Because then now that you have a common denominator, you need either two of them that add up to a 1 pi for the numerator or subtract to be a 1 pi. And there's some different options. So we might not all do it the same. I'm going to go ahead and take 4 pi 12ths and 3 pi 12ths. You could have used 3 pi 12ths and 2 pi 12ths. It could have been either way. So there are choices. But I can make this. So cosine of pi 12ths is the same as cosine, and I'm going to need parentheses if I do the pi thirds minus the pi fourths. Because that would be the 4 pi 12ths minus 3 pi 12ths, which is 1 pi 12th. All right, so now I need that cosine of a difference, of which, again, the cosine of the difference I need to have cosine, of the first angle, and then it's cosine of the second angle. And on cosine, when it's a difference, it's adding the terms. Then we change to sine, and we do sine of the first angle times sine of that second angle. So following the pattern. This first angle is the first one here and the first one here, so that pi thirds needs to be here and here. And the second angle is in the other spots. And then from there, it should just be easy because it's evaluating cosine of pi thirds. Again, I'm just thinking go short and long. Cosine is 1/2. Cosine of pi fourths is root 2 over 2. I need the values directly underneath them so that I can tell what you're using. Sine of pi thirds is root 3 over 2, and pi fourths is root 2 over 2. And we end up with a root 2 over 4 plus a root 6 over 4. And root 2 plus root 6 is not root 8. You can't add those. They are not like terms. And so there is your exact value. And we used a sum formula. All right, so now we're going to move to tangent. So I'm going to go grab those tangent formulas and put them up here. Or down here, whichever way you want to look. So we can kind of look at these. And so evaluating a trig function and show sum and difference formulas. So much like we did in the last one, I need to be using my 30 degrees, my 45 degrees, my 60 degrees, or continue. I can even use 90 if I want, and zeros, and 120s, and 135s, and 150. I need to use a couple of those so I can come up with 75. Either adding or subtracting. And there's more than one way to have that happen. But the easiest ones I'm thinking right away is, well, if I add 30 and 45, I get 75. So that works pretty nice. So I'm going to rewrite tangent of 75 degrees as tangent of 30 degrees plus 45 degrees. And then I'm going to follow this pattern. Now on tangent, you have a fraction. And in the numerator, whatever this is, you are adding. And the denominator is the opposite, you're going to subtract. So the numerators match in terms of addition, and the denominator, then you have the opposite. So in this next one, when you're subtracting, the numerator you're subtracting, but in the denominator you are adding. So if I look at this formula, in the numerator I have a tangent of something, and since it's addition, it matches, and another tangent of something, and it's the tangent of the first angle plus the tangent of the second angle. Then in the denominator, I have a 1, and it's the opposite. If I have addition in the numerator, it's subtraction here. And then I have the product of the tangent of the first angle times the tangent of that second angle. So looking at the order, I want it to follow the formula. So now we're going to need to evaluate these. And so you need to have your equals, come down, have the long fraction bar, tangent of 30 degrees. Again, at 30 degrees, right? At 30 degrees, you are to the right root 3 over 2 and up 1/2, and tangent is y over x. It is y over x. And so you have a 1 over root 3. And tangent of 45 degrees, I always go, that's the nice one. It's 1 because at 45, x and y are both root 2 over 2. Sorry, that's kind of small, but you should know what it is. And so y over x is just 1. And then I have a 1 minus tangent of 30, 1 over root 3. And tangent of 45 is 1. And so then I'm going to get a common denominator. And so I can add these. And so I am going to multiply this 1 by root 3 over root 3. And I multiply this 1 by root 3 over root 3. It's supposed to be a root 3. And so this is going to be a 1 over root 3 plus root 3 over root 3. So I have a common denominator. And a root 3 over root 3 minus 1 over root 3. Which means I have a 1 plus root 3 over root 3. A root 3 minus 1 over root 3. And hopefully you kind of know by now that then those root 3's will just cancel. What's happening is I have a 1 plus root 3 over root 3, and I'm multiplying by the reciprocal of the denominator, and those cancel, giving me that 1 plus root 3 over root 3 minus 1. But now there's a format issue. We don't like radicals in the denominator. So to get rid of those, we multiply by the conjugate of the denominator. So bringing back some old skills. So we're going to multiply this by root 3 plus 1, top and bottom. And in the numerator, what happens is it's really a 1 plus root 3 squared. Which is your 1 plus 2 root 3 plus 3. So that numerator becomes 4 plus 2 root 3. And the denominator, you just get 3 minus 1, because it's that a squared minus b squared, which you have 4 plus, so part of this is just being able to go through and simplify. Oops. After you've evaluated. And now you can divide both of those by 2 and you get 2 plus root 3. Make sure you have enough detail in that as to how you simplify, and you do need to simplify. So, once you've evaluated it, the new part of this is over. The rest of this is working with fractions and getting common denominators and rationalizing denominator skills. All right, so rewriting a trig expression as a sine, cosine, or tangent of an angle. So this is going backwards. When I start looking at this, so write it as a trigonometric expression. And I'm seeing here cosine, cosine, sine, sine. I'm like, oh, that reminds me of some different formulas. And the one that uses cosine, cosine together and sine, sine are the cosine ones. So I'm going to go back and grab those cosine ones and see if I can kind of compare them and figure out which one it is. But I have to recognize, hey, those are those cosine ones. So remember in cosine how I said if it's subtraction here, it's going to be the opposite inside here. And so I have to realize, oh, well, this is cosine of, and then the u in both of these is the 130. And when it's subtraction right here, it is addition here. And then the v is that 40. So then you need to add that together and write it as cosine of 170, and you need the degree symbol on that. All right, well, then we have the tangent formulas. And so if we go back and we look at those, I guess I can grab them and make them small. So if I can copy those and bring them down, so you can have like a worksheet right next. So here's my tangent ones to refer to. And on the tangent one, when the numerator is subtraction, whatever's in the numerator, that's the sign inside that tangent. And so this is going to be tangent, and it's going to be subtracting the two angles. And the u in this case, that u is pi fifths. And again, the numerator has subtraction, so this is subtraction. And the v is the pi 30ths. And then you just need to know that you can get a common denominator, multiply pi fifths by 6 over 6. You have a 6 pi 30ths minus a 1 pi 30ths. Now that you have a common denominator, you get tangent of 5 pi 30ths, but it keeps giving because this is tangent of pi 6. And so you can go ahead and write. You can actually, if they ask you to simplify, or if it asks to evaluate, then you would need to keep on going and know that the tangent of pi 6, at pi 6, remember this is root 3 over 2 and up 1/2, so tangent's 1 over root 3, or root 3 over 3. So if it asks you to evaluate, you need to get to this. All right, so right here it says find the exact value. So we're going to have to evaluate. And when you have a sine and a cosine mixed right here, and then it switches cosine sine, that's one of those sine formulas. So again, if I come back here, do a little cleanup, and grab these. Okay, so on the sine, whatever is here is the same. Remember, on the sine, the signs, S-I-G-N, are the same. So if it's addition of angles, you're going to be adding the two terms. So since we're adding the two terms, it's the addition of the two angles. So this is going to be sine of that first angle pi 12ths plus that second angle pi 6. And now you're going to get a common denominator. So this is sine of pi 12ths plus multiply by 2 over 2, 2 pi 12ths. So we have sine of 3 pi 12ths, which is sine of pi fourths, and you have to evaluate it, and you get root 2 over 2. All right, and then in example 3 here, this last one, we've been seeing these before where we have a trig function and they give you a quadrant that angle is in, and then they give you another trig function. So this is going to double this up a little bit. And that second angle is in a different quadrant. So what you need to do is set up two triangles, one for the angle U and one for the angle V. So set up two triangles, one for U and one for V. So when you have this sine U is 7/25, sine is opposite over hypotenuse. And so U is in the first quadrant, so just draw a triangle. And here is my angle U. And so this would be 7, this would be 25. And you use Pythagorean's theorem to find x. Or else you just know as you do that you're going to get x is 24 because it's one of those Pythagorean triples. Now you can find all 6 trig values of U. That's why we wanted to do that. Then you need to set up another one for the cosine of V, but V is in your second quadrant, and we have cosine of V is -4/5, and that's adjacent over hypotenuse. So this would be -4, this would be 5, and so we're setting up for y. -4 squared is y squared equals 5 squared, or that's one of those 3, 4, 5 triangles, another nice Pythagorean triple. So this is going to be 3. Now you can find all 6 trig functions. Remember, in the second quadrant, only sine and cosecant are positive. All the other 4 are negative. And then they want you to find the exact value of cosine of U plus V. Well, we are in the section where we are using the addition formula. So you need to write down that addition formula. With cosine, you have 2 cosines, but when it's addition, it's subtraction. And then you do sine, and again, you put the U first and the V second. Now you already have 2 of these values. you have the cosine of u is negative 4/5. And you have the sine of u is 7/25. Those were given. But that's why we had to set up the triangles, because when I want to do the sine of v, I need to come over here and go, well, sine is opposite over hypotenuse, and sine in quadrant 2 is positive, so it is going to be positive 3/5. But then I need to do the cosine of u, and so when I'm doing the cosine of u, I need to be in this top one where we have the angle u, and cosine is adjacent over hypotenuse. And cosine in quadrant 1 is positive, so it will be a positive ratio. So then I'm going to have a 125 here, I'm going to have a 125 here, and 24 times 4, I'm going to have a negative 96, minus, and then 3 times 7 is 21. So it's a negative 96 minus 21 all over 125, which is a negative 117 1/25. And that's the exact value, and that's the work you need to show. I need to see the formula, and I need to see what you wrote. I have to have the formula written down to know that you're substituting each one correctly. There you have it.